Just tell us a little bit about yourself and a little bit about your experiences, how you've come here to the X-ROTOR project, and then a little bit about your role on that project.
Sure, yeah. So I guess it started mainly during my master's thesis. I was doing experimental work looking at dynamic stall on vertical axis wind turbines, but more specifically the traditional H-type Darius vertical axis wind turbine. And that really kind of stimulated my interest in experimental work applied to renewable energies, turbines. But vertical axis wind turbines is especially interested in me because that's where more of the complex aerodynamics is involved. So that being said, how I ended up in the X-ROTOR project, well, after my master's thesis, I was looking for PhD opportunities in the field of experimental aerodynamics in turbines. And I was super lucky that at the TU Delft, Carlos was advertising such a position. So I applied, and I was very lucky to get accepted. And it's pretty much everything a PhD I think can dream of. You know, a very novel concept, not much literature going around on the aerodynamics, the aeroelastics, which is what we're working on. So a field very ripe for scientific novelty, let's say.
Okay, all right, great. How long have you been? How far along in the program are you?
Yeah, so I'm I think about 4 months away from finishing my second year. So about 1.5, 1 3/4, let's say. So I still got a bit more to go. I think about 2.5 years.
Okay. Well, like I say, it's a good project. It's a good project to work on.
Yeah. So I work mainly on work package 2 of the project, which is the aerodynamic and aeroelastic characterization, let's say, of the X-ROTOR. So I work on experimental validation, let's say, of the X-ROTOR model, specifically at this point more with the aerodynamics. So I'm taking a look a lot at the flow field, both within the volume of rotation, but also in the near and far wake of the X-ROTOR as well. And the idea is hopefully that we can use these experimental results as a benchmark to validate the numerical models that are being worked on, not only in Delft, but also with the other consortium members at Center and also at Strathclyde. So that's something that we're trying to do now in the near future. We have quite an abundance of experimental data, so which is also a great problem to have. But so actually doing the validation and improvements on the models is yet to come.
Are you finding that with the modeling of the wakes from the turbine that you would be able to place them closer together, place them close together, maybe just rotating in different directions?
Absolutely. I mean, that's actually something we took a look at in our last experiment. Well, I mean, it's a two-parted thing. I mean, one idea, which was my first intuition when going in, it was now that we have these cone blades on the X-ROTOR, in contrast to the straight-bladed H-type turbines, I imagine that we would have this extra three-dimensionality in the flow field, which would probably increase the level of mixing and the re-energization of the wake, specifically in the far wake. So that's something that we've not collected data, so we'll try drawing some more conclusions on this. I suspect it will be positive. But we also took a look at actually applying fixed pitch offsets to the blades, which has been shown now in really recent studies by some people at TU Delft, that by pitching the blades, even just with a fixed pitch of, let's say, plus 10 degrees or minus 10 degrees, there's a very small penalty on the power production of the turbine, but you can re-energize the wake exponentially. So this has a huge impact on, the power density of, let's say, potential wind farms offshore. We can place them much closer together, since wind resource offshore is quite limited, especially if you want to do fixed bottom, or I guess if you want to look into floating, it's a different question.
Right.
But yeah, that's a lot of potential there, I think.
Okay,